chapter 1, you still have to read the chapter before the test. That's very important. If you're taking careful notes, that's great. If you're using the PowerPoints, that's a good starting way of reviewing the chapter, but is not a substitute for reading the chapter. So please read the chapter, be prepared. I am hoping that you have your financial calculators. I will do the lecture today. If we finish early, then I will do maybe one example. I was able to get one example in the morning session, and I will show you some things about your calculator on Wednesday. So by Wednesday, if you have not purchased your calculator, you have to have it by Wednesday. That's very important. Otherwise, you have to figure it out on your own, or you have to come to office hours. I'm not going to spend class time to give you individual instructions after Wednesday. So pay attention to that. Remember, if you have not purchased your calculator, you have a choice of 3 calculators only. Your calculator in your statistic class is not going to work. That's the scientific calculator, is not a financial calculator. So your calculator for this course has to be one of the 3 calculators listed in the syllabus. So pay attention to that. Don't waste your money buying something else because this is a face-to-face class. So if I see you using a different calculator during the test in class, I will not let you use it. And taking an exam without a financial calculator will be difficult. So please pay attention to that, all right? Also, you need to have registered for Connect. Please do so. So if you run into complications, you can contact Connect people and set everything straight so you can do your homework and submit it on time. All right. If you have any questions, go ahead. If not, I will start by sharing my screen with you.
Professor, really quick, for the Connect, I'm logged in right now and it still says that you haven't assigned anything yet. Is that correct?
That's correct.
Okay, just making sure.
Yeah, I will open the homework probably on Wednesday. I like to lecture. I like to give you some examples, and then I like you to, then I will let you go on and to the Connect and do it. You see, I have given you an opportunity to use the practice and use the practice to do the homework assignment. I don't want you to copy and paste. I want you to learn something from that. That practice thing is set up so you will not get frustrated. You will find answer to some of your questions, especially those of you who don't want to come to office hours. Oh, one more thing. If you go to Canvas, to files in Canvas, you will see a link for tutoring. We have a tutor available for this course. The information is in the attachment. So if you are interested in using a tutor, we do have a tutor. You get the information about that from the Canvas. Okay.
Professor Sarmas, I don't know if any other students have had this issue, but when I went to my course materials, it says that I'm opted in for Course Connect, but there is no option to get straight to it from Canvas. So
no, you have to go from my link.
From your link, direct.
From the link in the syllabus.
Okay, thank you so much.
Yes,
that clarifies it.
Okay. That's a good point. I don't know why they put that in the Canvas. I am not connecting my Canvas to Connect. I don't want that. There's some funky stuff happening which creates complication. So if you go to my course syllabus, you will find the link in a very large fonts. You click on that, it will take you to the registration page and you can register there. All right. What you see on the screen is I'm sharing with you is the Word document of my notes. And again, I said to you, if you remember, let me make sure that I am actually sharing that, and you can see it here. Yeah, you should be able to see it. If you are not seeing it, let me know. These are my lecture notes. This is for me to be organized in presenting material to you. I'm not going to let you use it. You can take screenshot of it. You can write it down. Main purpose is for me to slow down as I am talking, to give you an opportunity to write down what's going on. So take notes if you're interested. The same material will appear in the PowerPoints that are available to you, open to you, and the same material is in the chapter in your textbook. Okay, this chapter, chapter 5, deals with time value of money. So this is a lecture in chapter 5, time value of money, and essentially tells you that money has money has time value. Okay, what does that mean? That means if you notice that timeline on the screen, on top, I have two boxes, one indicating 0, the other one indicates 1. 0 stands for now, today. Okay. 1 indicates end of 1 year, end of 1 period. So the period can be 1 year, the period can be 1 month, the period can be 1 day, is a period. In most cases, in your homework assignment, the period is 1 year. So please write this down, pay attention to it. Notice the arrow here I'm putting. This indicates essentially that this is end of year. This is 0 indicates now, today, or make a note, or the beginning of year 1. So beginning of year 1 is when time 0. End of year 1 is year time 1. 1 is end of year 1, 0 is now or beginning of year 1. You have an option. You are given an option of $1 now, today, and $1 1 year from today. Which one would you pick? Normally, if I, pardon me?
Today.
Today.
Very good, very good. Thanks. I'm glad you answered. Normally in the class face-to-face, I have to go and stand in front of the student and intimidate them in order to get an answer. Today, okay. Most of you probably were thinking today, wanted to say today. The question I will ask next is why? And most of you probably will say $1 today will buy more than $1 next year. Okay, so in other words, $1 today has more purchasing power than $1 next year. The purchasing power of $1 refers to inflation. The inflation lowers the purchasing power of $1. Okay, I put gas in the car. I go to Costco and I put regular gas at, I used to put it at, let's say, just approximately, used to be about $4, okay, for per gallon of regular gas. Then what happened a few months ago now is $4.20. So there is about 5% increase in price of gasoline. That means if I use the same $4, I will not get the same amount of gas. Or the same amount of gas, it will take more dollars. what is my point? The dollar does not buy you the same thing. What I used to buy for $1 last year, I'm not able to buy this year. So now we are talking about the purchasing power of $1. So if you think of it this way, you would prefer $1 today to $1 next year. It makes perfect sense because the dollar today will have more buying power. Then I will go to the student who said they prefer $1 today because of inflation. I will say, assume inflation rate is 0. Assume there is no inflation. Which one would you prefer? $1 today or $1 next year?
Today.
Student, go ahead.
Today.
Today again. Why? Can you tell me?
Well, I can spend it today.
Say that again.
I can spend it today.
Very good. You can spend it today, but hold on to that if that's what you said, or you can invest it.
Also,
Okay.
the risk factor, the fact that you can get it today is promised, and then tomorrow may not be.
Very good. Okay, you are a step ahead of me. Yes.
Well, I guess
But-
it depends on who you're, like the stipulations of you giving that dollar out. Will you account for the value, the monetary loss of not being able to spend the money, inflation, etc. If you account for those things, then maybe $1 tomorrow might be worth it.
This is essentially, let's put it a different way that you put it. If the inflation rate is 0, and if interest rate, if somebody said, okay, I invested today and earn interest. So it makes sense. If you get $1 today, you put it in the bank, you earn interest, you will have more money next year. Rather than getting $1 next year, and you have lost the opportunity to invest it. I'm listening.
Oh yes, I was gonna say it's similar to kind of what you were mentioning about, if I'm correct, Sears,
Yes.
about how it took them, was it 3 months for any transaction to come back? That they cannot pay anything, they cannot pay any of their liabilities off because they don't have the money, for 3 months, and that's not necessarily.
100%.
You can adjust to it. Like, let's say people adjust in the same way that, like, if people get paychecks, bi-weekly versus, once a month. Some people get paid once a week, but I think most people would say they would prefer to be paid once a week. If anything, just so the money comes in at a more constant rate and there's less of a wait period to get the money.
Exactly. You are 100% right. And at the same token, the company that pays your salary, your wage, would prefer to pay you once a month. In fact, if they can get away with it, they prefer to pay you maybe once a quarter, once every 3 months. And why? Because they can sit on the money and earn interest. You want the money faster because you can take it, put it in the bank and earn interest. If you take it every week, you can put it in the bank and earn interest. If you get it twice a month, once every 2 weeks, then you will not earn as much interest. Exactly what you said, yes. And the same with Sears, not having that money for 3 months, it affected them. Not only they could not do business, but they lost the ability to put that money in the bank and earn interest. But if we put interest rate at 0, there is no interest, 0. In fact, for the past 3 years, interest rate has almost been 0. That is, the banks pay very, very little interest. I did a lot of major purchases using my savings. It didn't pay off for me to borrow money and buy a refrigerator and pay 3 or 4% interest, whereas my money was sitting in the bank and earning almost 0% interest. So I use cash to do the purchases. So when interest is 0, then my question becomes, there is no difference between $1 today and $1 next year. that brings me to the other point somebody made, risk. That is the certainty of the money. You have the money, you can spend it now, you have it now. What if next year comes and I forget to pay you $1? What if I go bankrupt and I don't pay you the $1? What if I die? You don't get $1. All right. So there is a risk involved with waiting 1 year to get that $1. Whereas $1 today at time zero is certain. It has no risk. So all this discussion tells you one thing that you summarized very nicely, a couple of you, that $1 is preferred today because it has more purchasing power because of inflation. So equate purchasing power to inflation. Okay, your purchasing power goes down as inflation goes up. So purchasing power, dollar is worth more today because it has ability to earn interest. You can take $1 today, put it in a bank and earn interest. And the dollar today is more certain. All right. There is no risk involved with it. So these are the reasons that we assign a greater value to $1 today than $1 in the future. This becomes an important issue. I remember a few years ago, about 6 years ago, a couple of students, CIS majors, who were graduating, came to me with a question. It was a very interesting question, and they were supposed to be able to answer it, but they had forgotten their FRL 3000. The question was, the major was very hot, and the companies were willing to hire students, not only pay them a very high salary, but also to basically give them bonuses, sign-in bonuses. So students came and said, I am offered $60,000 a year plus $10,000 bonus. And then alternatively, they say that they are willing to pay me $70,000 a year with no bonus, with no sign-in bonus at the beginning. So $60,000 a year plus a sign-in bonus of $10,000 versus $70,000 a year. And the student said, I think there is no difference. I said, oh, there is substantial difference. The fact is you get your $10,000, but your salary from after 1 year will be $60,000. But if you sign on to $70,000 deal, don't get the $10,000, then your salary will continue at $70,000. If you get any pay increase, will be based on $70,000, not $60,000. So which one is a better deal? All right. So you have to wait 1 year over which you get $70,000, but you can get $60,000 over the year plus $10,000 right now. We have to do that calculation because those dollar values are different. That becomes a very relevant issue. This topic is very relevant. You hear often in the area of sport that certain football player, a baseball player, or a basketball player gets, let's say, $100 million 5-year contract. Okay, so you automatically say this guy will make about $20 million a year. Now you have to realize that he gets $20 million a year over 5 years. That's $100 million, but the club does not pay him $100 million. It is not costing, let's say, Lakers or Rams or Dodgers $100 million to get this athlete. What they happen is that because they pay over the year, they can put a smaller sum in the bank, earn interest, and then over the year they pay 20 million, 20 million, 20 million, and so forth. So that time value of money becomes very important. So when you look at the dollar, you cannot look and say a dollar today versus a dollar next year is the same thing. You either have to find the future value of a dollar today to see if you get a dollar today, how much is that worth 1 year from now, or to get the dollar 1 year from now and find out how much is worth today. Please pay attention to the bottom of the screen. If you are calculating the value of a dollar today, if you're taking a dollar today and calculating its value 1 year from today, the process is called compounding in that box on top. Compounding. Compounding, please make a note, compounding is calculating future value. Compounding is calculating future value of a dollar today. Compounding is calculating future value of a dollar today. Otherwise, if you are about to receive some money in the future, if you have a dollar 1 year from today, you want to see how much is that worth today. Because we already agreed a dollar 1 year from today is not the same as a dollar today. So you say, okay, I have a dollar 1 year from today. How much is that worth today? That process going from future to present is called discounting. Discounting is calculating the present value of a dollar received in the future. Excuse me. It's calculating the present value of a dollar received 1 year from now. So discounting is calculating present value. Compounding is calculating future value. Be familiar with these terminologies. I can ask you conceptual questions on the test. Okay, and in the meantime, if you have any questions, feel free to ask me. Interrupt me.
Could you repeat the definitions for discounting?
Would you just be able to type them?
Oh,
your document, please?
Okay.
Thank you.
Compounding is calculating the future value of a dollar, of $1 received today. So you essentially think of it this way. You go from present to future. That is called compounding. Okay. So pay it. My main focus here, my main focus is compounding is future value. Discounting is calculating, what did I do? Okay. Discounting is calculating the present value of $1 received in year 1 today. Let me put it this way. This may be calculating the present value today of $1 received in year 1. Okay, so discounting is calculating present value. Compounding is calculating future value. Once again, compounding is going from now, year 0, to year 1. Discounting is going from year 1 to 0. Okay. All right. This chapter is very easy. It has one formula. Write it down. You're looking at it. Future value is equal to present value times 1 plus R interest to the power T. FV is future value. PV present value. R is interest rate. T is period. So if you take present value times 1 plus R to the power T, that will give you the future value. That's how you calculate it. If you look at this formula, it has 4 variables. Present value, future value, present value, interest rate. Let's see if I can find a color that you can see. Period. 4 variables. T is period, R interest rate, PV present value, FV future value. 4 variables. Now, please make note. This is it. This is chapter 5. I'm done lecturing chapter 5, if I can say, all right, which I'm not done. I want to give you more information. Okay. If I look at this, if I give you any 3 variables, any of those 3 variables, I can ask you to calculate the 4th one. This is what I mean. I can give you present value today. I can give you interest rate. I can give you period. Ask you to calculate future value. I can give you future value. I can give you interest rate. I can give you period. Ask you to calculate present value. I can give you future value, present value, and period. Ask you to calculate interest rate. Or I can give you interest rate, present value, future value, ask you to calculate the period. All right. So any 3 variables can be given. As long as I give you 3 variables, any 3, I can ask you to calculate for the 4th one. So that will be your homework assignment. It will be dealing with, and you will be tested on. All right. Now, fortunately, you have these financial calculators, so you don't have to write mathematical equations to do that, but you have to be familiar with your calculator. When we talk about interest, we are talking about simple interest and compound interest. That distinction you have to be able to make. That's very important. Simple interest, as you can see, is where your interest is earned or charged on principal only. So every year you get paid interest on the principal amount that you put in the bank. So $100 you put in the bank today, by end of the year, next January, you get 10% interest, that's $10. The following January, you get another 10% interest, that's $10 again. You always get 10% on top of your principal. That is called simple interest. Simple interest, where interest is earned or charged on principal only. Compound interest is where interest is earned or charged on both principal and interest from the previous period. So this is what happens. You have $100, you put it in the bank at 10% for 1 year. At the end of the year, you get 100 plus 10% interest, $10, that's $110. Then on the end of second year, you get 10% on $110, where the interest will be $11. I hope you can see the difference. Compound interest pays you interest on both the principal and the interest from the previous period. So if you're saving money, you prefer compound interest. But if you're borrowing money and you have to pay it, you prefer a simple interest. Nowadays, in real life, most interest is paid on compounded basis. Banks pay interest or charge interest on compounded basis. Any questions?
So like credit cards now are mostly compound interest methods?
All of them are compound interest methods.
Okay.
And say that example, okay? You stay with me because I'm going to say something about the credit card in a moment. In fact, it's on this page, is the last bullet. But this relationship, you will see it if you understand what you do with the calculations. You will see that relationship very clearly as you calculate present value and future value. However, I want to bring it up because I'm going to ask questions on the test, and I want you to basically be quick in answering those questions instead of spending time thinking about it and trying different numbers to see what holds. Now, this is what I'm saying. If inflation or interest rate, doesn't matter, interchangeable here, either one. If inflation or interest rate increases, goes up, if inflation and interest rate increases, future value will increase, present value will decrease. One more time. If you have two banks, Bank of America and Citibank, if you put the same amount of money in each bank, and Bank of America pays you 6%, Citibank pays you 8%, the future value, you will have more money in the Citibank than in Bank of America. So at higher interest rates, the future value will be higher. Now, what if you want to save $100 by next year? By next January 31st, 2023, you want to have $100. Bank of America pays you 5%, Citibank pays you 8%. Which one do you have to put more money in?
City?
Bank of America, the one that pays you lower interest rate. Remember, you want $100 by next year. One bank pays you 5% interest, another bank pays you 8% interest. So if you put your money in Citibank at 8% to get 100, you will need to put less money because you have higher interest rate to earn. But if you put it in the Bank of America, which pays you only 5%, then you can get away. You have to put more money in at lower interest rates. So as interest rates increase, what will happen to the present value? It will go down, decrease. Higher interest rate, lower present value. Higher interest rate, higher future value. Make that distinction, that relationship is important. Time period. The longer time period, higher future value. It makes sense. You save money for a longer period of time, you end up with more money. Higher time period, higher future value. Longer time period, smaller present value, lower present value. One example. Okay, we have Jessica out there. Jessica and I both want to have $10 million in our savings account by the time we are 75. By the time Jessica and I are 75, we want to have $10 million. Make a note. I am 67 years old. We are not going to ask Jessica how old she is. Okay. I am 67 years old. Jessica is your classmate. We both want $10 million when we are 75. Which one of us has to save more money today?
You.
You. Me. Not you.
The
Me.
professor.
Okay, exactly, 100%. I only have 8 years left to have $10 million. Jessica has decades, okay, 50 plus years to come up with $10 million. The longer the period of time involved, the smaller, the longer the period of time, the smaller the present value. My period of time is short, my present value is high to get $10 million. Jessica's time period is long, her present value is small to get $10 million. So when you hear older people, your relatives, mom and dad, they keep telling you, save your money, save your money. I'm sure you have heard that. If not, you will hear it, okay? Why? They're telling you to do something they didn't do. So they learned their lesson, so they're giving advice to you. So that being the case, the idea is if you start saving now, you will end up with more money by the time you retire. That's the idea. That's all it takes. Okay. So we talked about interest rate. We talked about time period. Let's talk about number of times interest is compounded. Interest can be compounded or paid or charged once a year. And for chapter 5, all examples will be based upon that assumption. Chapter 6, we will change that. We will change the assumption. Chapter 5, we assume interest is paid once a year. But interest can be paid twice a year. We call it semi-annual. Interest can be paid four times a year, quarterly. Interest can be paid daily, every day, or monthly. So let's assume a bank can pay you 12% once a year, or a bank can pay you 12% every 6% every 6 months. So 6% in the first 6 months, 6% in the second 6 months, that makes it 12. Or a bank can pay you 12% 4 times a year, every 3 months, 3%. The first 3 months, 3% in the second 3 months, 3% in the third 3 months, and 3% in the fourth 3 months. Or they can pay you 1% every month. It will add up to 12%. All these examples, the interest rate is 12%. It's just paid in different frequency. It can be paid every day. So when Anne asked me about credit cards, that they are compounded, they not only compounded, but the credit card companies charge you interest on every day. Your car loan, the bank is charging you interest every month. The mortgages are based upon monthly interest compounding. So, and the bank pays you on your savings and checking account, the bank pays you interest at a fraction of 1 second, not every second, but fraction of every second. the expression is the bank pays you continuously. So make a note to yourself, a continuous compounding or discounting, continuous compounding or discounting means that interest is paid or received at the fraction of 1 second. If number of compounding increase from once a year to 12 times a year, if number of compounding increase, your future value will be higher. If the number of compounding increase, they go from once a year to 4 times a year, present value will be smaller, will decrease. So as number of compounding increases, future value increases. As number of compounding increases, present value decreases. Take a look at that. Make
It
sure you
says-
have, yeah.
The second bullet point says discounting increases, present value decreases. Is that a typo then?
No, compounding, remember, compounding, because I'm calculating future value in the first sub-bullet, I call it compounding. And because I'm calculating present value in the second sub-bullet, so the term changes to discounting. This goes back to what I had on top here.
Gotcha. I see
Yeah.
that.
It goes
Thank
back to
you.
this.
Got it. Thank you.
Sure. Okay, the formula that you see this formula here. Future value is present value times 1 plus RT. This term, 1 plus R to the power T, the last term, 1 plus R to the power T, has a name. It has a name. You need to be familiar with that. It's called future value interest factor, FVIF. FVIF is future value interest factor, which is equal to 1 plus R to the power T, because you're calculating future value. So you can write this formula. You can write this formula. Okay, say present value times 1 plus R to the power T, or you can say present value times FVIF. Okay. So FVIF is the same 1 plus R to the power T. Now, what if you're calculating present value? So the formula changes just a bit. Here, you take FVIF, you take future value divided by 1 plus R to the power T. Here, this is what I'm talking about. You take present value is equal to future value times 1 plus R to the power T. So that's to calculate present value. Here, you're calculating future value. I can rewrite this as future value times 1 over 1 plus R to the power T. Instead of writing future value divided by 1 plus R to the power T, I can say future value times 1 over 1 plus R to the power T.
Samsung Galaxy S10, your mic is on.
Okay.
Wait, so like for the test, are we gonna need to memorize these formulas, or would they be just given?
No, they're in the formula sheet.
So we don't have to memorize.
There is only one formula. This is the formula. This is the only formula. But you manipulate. What is your question? Calculate FV. This is the formula. Now, what if you need to calculate present value? Then that's very easy. You manipulate the formula. Take FV divided by 1 plus R to the power T. What I want to point out is if you write that as 1 over 1 plus R to the power T, it has a name. is called PVIF. And PVIF stands for present value interest factor. Present value interest factor. Now, none of these matter to you because you have financial calculator. But when I was taking this course in 1974, almost 50 years ago, we did not have financial calculator. So what did the publisher do? The publisher calculated 1 plus RT and 1 divided by 1 plus RT and put it in a table for us. Anyone in the class who has the textbook, physical textbook?
Yeah.
Okay. Do me a favor. Go to the end of textbook, Appendix A, and go to Table A1. Let me know when you're there.
I'm there.
Okay. Pick, you see the table, pick any interest rate for any period. Pick one period, one interest rate.
Okay. Period 69%.
Period 69%. So let me see. If I take 1.09 to the power, where is the 60? You can tell the class if this is correct. 176.0313.
That is correct.
Okay. Now, I write this number I'm going to give you in a moment. Let me find the proper key. Okay. 0.0059. Do you have it down? 0.0057. Sorry, 0.0057.
What is that? This one?
Okay. Go to table A2. Go to table A2. Look at the interest rate you picked. Was it 9%?
Yeah.
60 per year. What do you see?
In my table, I don't get it only goes up to 50 periods. For table 18 for some reason.
For A2 doesn't go to 60?
No, it only goes up to 50 periods.
Okay. Then in that case, let's go back to table A1 and pick 50. Let me see. At 9%, 50, check the table A1, and you should have 74.3575.
Yep.
Okay. Now, if you go to table A2, you should have 0.0134.
That's correct.
Okay. You see, I took the table A1 is FVIF, future value interest factor. Table A2 is present value interest factor. And for my calculations, you can see that they are inversely related. That is, if you invert PVIF, you get FVIF. If you invert FVIF, you get PVIF. And this is how we did it without the calculator. The book gave us the calculations for interest rate and period. Now, the only thing was that our professors sometimes got nasty. And instead of saying, okay, what is the future value at 9% and 50 years? They said, what is the future value at 9.5% and 52 years? The table doesn't have 52 years and doesn't have 9.5. So this is what I did. This is what we all learned to do, something called linear interpolation. We said the table tells us 9% 50 years, and the table tells us, for example, 10%, 50 years. Let's say 10% 55 years. So I'm going to work out the differences here to find the interest rate at 9.5 and 52 years. So we went through a lot of calculations to come up with PVIF and future FVIF. You don't have to do that. You have financial calculators. So that's done. The only thing I want you to get out of this is that the FVIF and PVIF are inversely related. The one is the invert of the other one. So don't worry about going to the back of the table for calculations. You will use financial calculator. What you see, the table you see on the screen, you don't have to worry about writing it down. Don't write it down. It's a pain in the neck. You want to take a snapshot of it, that's fine. But I have it available to you on Canvas. If you go to Canvas, if you go to filter, no, you don't go to filter, sorry, to files. If you go to files, if you go to Canvas, you go here. You're seeing it. If you go to Canvas, you go to files, and if you scroll down, you see use of financial calculator. The first file, the first file, calculators instruction, it has this page. This tells you how to set up your decimal points. In fact, if you have your calculators, let's do it for those of you, and we will go over that on Wednesday as well. Let me see. Let me ask you this thing. How many of you have HP 12C? Anyone with HP 12C? That's an odd calculator, more expensive than the other two. Very good. So I assume you either have Texas Instrument or HP 10B.
I actually have both the Texas and the HP 12C.
12C? Okay. If you have questions, then you can ask me. I will show you on 12C as well. Okay. So let's do this now. Let me, where am I? Okay. Let me go back to my notes and, oh, here it is. You can see both calculators. Am I right? If you cannot see, let me know. You should be able to see both calculators. All right. So I'm going to do Texas Instrument. This is what it says. First of all, to clear calculator. Okay. Pay attention. This is what you do. You press for Texas Instrument. You press this key here, CEC. You see, it makes everything 0. Then you press second and CEC. And then you press second FV. Here I have the second one. CEC, display screen goes to 0, then second key, FV, future value key. This clears the calculator. To change your decimal points, you press second, and the dot at the bottom of the calculator, in between 0 and plus and minus. It says decimal, DEC. You put in 4, put 4, and enter. Okay, second dot, press 4, you enter. It will give you 4 decimal points. Have you done it? Did you do it?
Yes.
Okay. Now let's go to HP 10B. the clear calculator is easy. You do this broken arrow, orange or pink key or orange key, whatever color it is, broken arrow, you press that and you press C. Okay, pink key, broken arrow, C, or clear all. That will clear your calculator. So it's easier with 10B than it is with Texas Instrument. And just one extra step with Texas Instrument. That to change the decimal points, I assume you don't have 4 decimal points. You will press the broken arrow, okay, right here, the pink key, and then display key, which is the equal sign. Display key, which is this the equal sign, and then you put 4, and that should give you 4 decimal points. Okay, now what I want you to do is try this. Try this item. For 10B, HP 10B, do pink key and C. And look at the screen when you do that. See if it says 1. And for Texas Instrument, do the second key and I key. Okay, I key is on top here. Where is it? There. Is the I key. Do second I. See if it says 1.
It does.
Everybody? Is it?
Yes.
Yes.
Very good. Okay. Make sure it says 1 because sometimes it says 12. So be aware of that. If it's 12, you need to change it. Okay. You need to change it to 1. So I will remind you again, and then next time we meet. Again, as I said, this is available to you on Canvas. All right. Again, this is an example. This is an example of what I meant. This relationship is very important. Notice I have 1, 2, 3, 4, 5. Each one of the numbers. 0 is now, 1 is 1 year from now, 2 is 2 years from now, 3 is 3 years from now, and on. So I want you to understand that very, very clearly. Where it says 4, that is end of year 4. And if you want to know where is the beginning of year 4, notice is at period 3. So period 3 is end of year 3 or beginning of year 4. I hope that's clear. Nobody is saying anything? Let me go back to Canvas. If you are on Canvas, you can go to where it says Files, In-Class Examples. You should be able to see chapter 5. If you do, download it. Download chapter 5. If you haven't done it, it's all right. Work with me.
Wait, where do we download chapter 5 from? I'm on like modules and I'll see chapter 5.
It's not showing a download link on my Canvas. Or is it under a different name potentially?
No. That's very strange. You cannot download it. Let's try something else.
They're all combined in one zip folder, all of the chapters. So if you just download that one zip folder, you can have access to all.
Oh, yes. That is quite possible. Yes.
Are we doing the Excel document on chapter 5? Is that the one?
Yes.
Okay, thank you so much.
So
Wait, how do you guys get there?
I got it from files. It wasn't in the chapter 5 module. You have to go in for class examples under files, and there should be an Excel file in there.
If you do files, you should have in-class examples. And if you click on that in-class examples, there's only one chapter visible to you. The rest are hidden. So you should have chapter 5 Excel file.
Yeah, I see it now.
Can you download it?
Yes.
If you cannot, that's fine. Just write down this example. Just write it down. I'm going to save my work here, and eventually I will upload this chapter 5 into in-class solution. Okay, so you will have it. Eventually you will have it available. So if you cannot get it now, you should be able to get it later. But if you try it, I want you to try it to make sure that we don't have any complications. Okay, you should be able to see the screen, and this is the example. Please write down the example. It's First City Bank pays 7% simple interest. Pay attention, simple interest on a savings account, whereas Second City Bank pays 7% compound interest. So both banks pay 7%. One pays simple interest, the other one pays the compound interest. If you deposit $62,000 today into these banks, how much more would you earn after 9 years, at the end of 9 years? So let me do the calculations. So we are talking about First City Bank. Are you ready to write down the solution?
Yes.
Yes.
Okay. The First City Bank, I'm reminding you, is simple interest. It means this. Annual interest will be your principal times interest rate, meaning you take $62,000 and you multiply it by what? 7%. Let me. So 7%, you can use your calculator, times 62,000. That's
4,340.
Very good, thank you. And now the total interest, that's annual interest. The total interest will be 4,340 times 9 years. So you take that and multiply it by 9, and you get $39,060. So future value, we use abbreviation FV, is equal to principal plus interest, which is 62,000 plus 34,060. You add these up.
$101,060.
I'm
Very
sorry,
good.
isn't it 39,060?
Oh, thank you. Yes. I think it still adds to 101.60. Double check it. I put the right number in the calculator, wrote it wrong here. So this is your first Citibank. What is second Citibank, which uses compound interest? Well, I gave you the formula. Okay. This will be just a bit odd, small when I write it. Present value, sorry, future value is equal to present value times, be just a bit patient with me. Oops. And then one plus 7% to the power 9. Let me expand that so you can see it. Hopefully you can see it here. Let me change this, sorry. Let me change this and then I put the original formula here.
Galaxy S10, you're on again, by the way. Thank you.
62,000 plus oops. Let's see, where is the equation? So it will be future value equals 62,000 times one plus 0.07 1 plus 0.07 to the power 9, which is equal to 62,000 times. Let me show you how to calculate that on your calculator. Okay, this is the original formula. And this is the calculation. Now you have to go to your calculator. And this is what you do. TI, make sure, Texas Instrument, you clear calculator. And I showed you how you do CEC, second key, and FV key. That clears it. So you do 1 plus 0.07 equal. The calculator will give you 1.07. You use the key y to the x. Y to the power x. If you look into your calculator, you should be able to see that. Y to the x. Then you put 9 and then press equal. The calculator should give you the calculator should give you 1.8385. For HP 10B, you do orange key, that's the arrow key, and then C key. That clears the calculator. In fact, let me say, clear calculator. And then you do 1 plus 0.07 equal. The calculator will give you 1.07. Then you use orange key and multiplication key. That will give you y to the x. If you look at your calculator, that is y to the x key. You put 9 equal, and you will get 1.8385. If you are not getting that, let me know.
The 1.83 is not supposed to be a dollar value, correct?
No, it's a factor. It's called future value interest factor, FVIF.
Right. It's a percentage in years and whatever.
Yes.
Yeah.
1.8385 multiplied by 62,000. And then you will see future value. I'm getting 113,984 and 47. So the difference, and that's what the question is 113,984, 47 minus $101,060. That will give you the difference. So how much more the second city bank pays is you take that, subtract 101 or 60. You will get 12,924 and 47 cents. That's the answer to the problem. I don't know why I want to show more decimal points.
Professor, I have a question.
Yes.
On my, I have an HP calculator and it just rounded by itself 1.84. Is that okay?
No, that's why I said increase the decimal points to 4.
That part. Okay, I'll fix that.
Okay. I don't know why this is 1.8385. Okay. Okay, this is better. All right, this is it. Thank you for being patient. I hope this is clear calculations. As I said, all these calculations, you can write them down. That's my suggestion. If not, I will save them and I will post them on Canvas. And we will do more examples on Wednesday. All right, make sure you have your calculators and make sure that you're ready to go. Thanks for joining me. See you on Wednesday.
So for like all the tests, are we gonna need to memorize? Are we gonna need to memorize all the formulas, or are you just?
There is no formula. There's one. No. The formulas will be given to you.
Okay.
And there is only one for. This is not. You see this.
Oh, yeah.
This is not. This is you memorize it. Because I'm telling you how to use your calculator. It will not be on the formula sheet.
Oh no, I'm talking about like later on, like for other.
Yes.
Formulas.
The formulas like this you will have on the formula sheet.
Okay.
You don't have to memorize.
Okay, thank you. All right,
Professor,
yes.
I got a quick question. I got the same answer for future value. The only thing is I inputted a different. I used the functions M, I, Y, P.
I will cover that on Wednesday.
Okay, I was just wondering if you wanted us to do it in a particular way, but I guess
no. In fact, I prefer to do it the way you have done it.
Okay.
I prefer your way, but I wanted to show you if you don't use the financial calculator, these are the steps you have to take. You add 1 to 0.07, then you find to the power of 9, and then you multiply by 62,000. You have to take all these steps. So my surprise on Wednesday will be, what if you use the functions on your financial calculator? How easy it is.
Okay.
So I want it done your way.
Understood.
Okay. Great.
Thank you, sir.
Thank you, Professor.
Take care.